In this lecture, we are going to look at two examples of inverse functions. Here's the first example. Explain why the function f, graph here, is not invertible on its domain. Then find three restricted domains on which the function does have an inverse. A quick reminder, a function is invertible if and only if the function is a one-to-one function. A one-to-one function also means that on the graph, the function will pass the horizontal line test. So why is this function not invertible? From the graph, we can see that the function will not pass the horizontal line test. For example, the line at y equals to 1. The graph passes through 3 points. But the horizontal line test says that the function can only have at most one intersection point at each horizontal line. So this function does not pass the horizontal line test. Then to find the restricted domains where the function is invertible, we can cut the graph into 3 sections so that each section passes the horizontal line test. The first domain is from negative infinity to negative 1. Then the second domain is from negative 1 to 1. And the third domain is from 1 to infinity. So over these 3 domains, the function will be invertible because over this restricted domain, the function is one-to-one and passes the horizontal line test. Now let's look at the second example. Consider the function f of x equals to 2x minus 2. A. Explain why function f must have an inverse. Then sketch the graphs of y equals to f of x and y equals to the inverse of f. And explain the relationship between these two graphs. Then B. Find a formula for inverse of f. And C. Algebraically verify that their composition functions, f of inverse of f and inverse of f both equal to 0. You can pause the video here and try to do the problem by yourself. So in part A, explain why the function f must have an inverse. By looking at the function, we know that this is a linear equation, and the slope is 2, which is non-zero, which means the graph of this function will pass the horizontal line test. So this function is a one-to-one function, and thus the function will have an inverse. Then the second part is we want to sketch the graph. In the first graph, it shows a graph of f of x, which is a linear line. It has a slope of 2, and the y-intercept is negative 2. Then to graphically find the inverse of this function, we draw the line y equals to x, and imagine this line as a mirror. Then we draw the reflection of each point from the original function, and that will be the inverse of the function. For example, this point, if this is a mirror, I will see a point here. And for example, this point at 1 and 0, I can switch the coordinates or imagine that this is a mirror. I will see this point here. And the coordinate of this point is 0 and 1. Then I erase the y equals to 0 in the original function. I'm left with this. So this is a graph of inverse of f. Then in part B, we want to find the formula of inverse of f. How can we do that? We are going to let y equals to f of x, which is 2x minus 2. Then we are going to solve for x. I can move the negative 2 to the left-hand side, so I have y plus 2 equals to 2x. Then I divide it by 2 to both sides. So I get x equals half of y plus 1. And the next step is to interchange the x and y so that I use x as the independent variable again. So the inverse of x equals half of x plus 1. And in part C, we want to algebraically verify that the functions that we just found is the inverse of function f by checking that their composition functions equals to x. Let's start with f of inverse of f. So the input to the function f will be inverse of f. So f of inverse of f is half of x plus 1. And function f is 2x minus 2. So I'm going to replace the x by the input, which is half of x plus 1. Then minus 2. This equals, I expand the bracket, I get x plus 2, then minus 2, which equals to x. How about the second one? Inverse of f of x. So now f of x serves as the input to the inverse of f. I have inverse of f, and f of x is 2x minus 2. So I substitute this to my inverse function. My inverse function is half times the input plus 1. The input is 2x minus 2. Again, I expand the bracket. I get x minus 1, then plus 1. And this equals to x again. And that is end of proof. So we just proved that the function that we found, inverse of f, and the original function f of x are inverses of each other. And that is the end of the section. After this lecture, you'll find an assignment on this section. Take your time to complete the assignment by yourself, and after you submit the assignment, solutions will be provided. In the next section, let's talk about the algebraic functions.